Right folks, here we go. We have a simple series circuit, two resistors in series with our source, okay, our battery here. I've got two cells connected together, or at least two cells connected together, outputting 40 volts. Okay, so remember that could be identified as VS, source EMF, or anything else in between. Okay, so normally when we're doing these calculations, if we're using the source voltage, we'll use the symbol E. Okay. In the circuit, we have two resistors connected in series. You'll see here that they are both two 100 ohm resistors. Now, one of the goals that we'll be looking for is to find out how much current is flowing through this circuit. Now, remember, in a series circuit, the current that flows in a series circuit remains constant. Okay. But before we can carry out that calculation using Ohm's law, we need to first work out what the total resistance is for this circuit. Okay, so step one, we have to calculate RT. So you'll see here we have two 100 ohm resistors, R1 and R2. So all we do is we just add those two resistances together, R1 plus R2. So that's 100 ohms plus 100 ohms. That gives us a total circuit resistance of 200 ohms. Once we have calculated that, then we have to calculate this current, okay? And again, as I said at the start there, we're going to be using Ohm's law. So the current that we're going to be measuring here is IT, okay, the total current. So what we need to do is we need to use Ohm's law. So rather than a V, we're using the E because it's the source voltage we're using, and we divide it by that total resistance. So we're using this value here that we just calculated in our Ohm's law equation, okay? So we take that 40 volts and we divide it by the 200 ohms. So 40 volts, which is the source voltage, remember it might be VS or source EMF or something like that. We take that 40 volts and we divide it by the 200 ohms that we've just calculated. That gets us a total current in the circuit of 0.2 amperes, okay? So we've 0.2 amperes flowing at every single point in this circuit, all right? Now that we've calculated that, what we have to do is we then have to calculate what the voltage is across each of these components, okay? So the first voltage that we're looking for is the voltage across this first resistor, and then we'll be looking for the voltage across this second resistor, all right? A couple of ways in which we can do it. We'll quickly chat about, we'll do the quick calculation method using Ohm's law, and then we'll have a wee chat about how else we could work out this V2, all right? So V1, we just use Ohm's law. We use that total current and we multiply it by the resistor 1's ohmic value, okay? So that resistor 1 is rated at 100 ohms, so we're taking 0.2 amperes and we're multiplying it by 100 ohms. So 0.2 amperes times 100 ohms, that gives us a total voltage across this resistor here of 20 volts. And if you look at the relationship between the 20 volts that we've got across this resistor and the source, you'll see it's half. All right. V2, we do the same calculation, but this time we sub in the second resistor's value, which is the same value as the first one. So 0.2 times 100, that gives us 20 volts. Okay, if we add these two values together, taking into account Kirchhoff's voltage laws and that closed loop, we then have 40 volts. Okay, another way in which we could have calculated V2 was to subtract this V1, because there's only two components, from the source voltage, and it would have given us the same 20 volts. Okay, so we've got 20 volts across this component, 20 volts